1.7 linear inequalities preparation. 1.7 linear inequalities preparation. So we're going to solve some more. These are a little more complicated. We solve them just like linear equations unless you divide or multiply both sides by a negative. Okay, so first step here is there are no fractions to get rid of. There are no parentheses to distribute within, but there are like terms to combine. So we're going to say 3x. Positive 2 minus 5 is going to give me a negative 3. On the right side, we have a negative x and we have a positive 2x. So negative 1 plus 2 is going to be a positive 1. So we have positive 1x plus 7. X, we want to get all the x's on one side. We get rid of the positive 1x on the right by subtracting x, and we subtract whatever we do to one side, we do to the other. 3x minus 1x is 2x. And we bring down the 7. Next, we want to get the positive 2x by itself by undoing the subtraction of 3 by adding 3. Whatever you do to one side, you do to the other. Cancel, cancel, leaving you 2x is equal to 7 plus 3 are 10. Next, we want to undo the multiplication of x by 2 by dividing by 2. Whatever you do to one side, you do to the other, giving you x is equal to 5. Okay. Let me fix that inequality, write the inequality instead. There we go. Okay, so now we are going to plot the number 5, which is right over there. We say x is greater than 5, so you know it's going to open up towards the right, which is where the arrow is pointing, right? And because there's no equal part, we are going to use a parenthesis. So it just opens up towards the right and goes on forever. Now, if you go to the right forever, there's an understood or implied positive infinity over there. So this one's going to start at 5 with a parenthesis, and we're going to go to positive infinity and then end with another parenthesis. Okay, the next problem, in this case, there are parentheses, so our first step on this one is going to be to distribute within the parenthesis. If there were fractions or decimals, we'd get rid of those first, but there aren't. So 5 times k is 5k. 5 times negative 3 is negative 15. We keep the negative 7k. We say 4 times k is 4k. We say 4 times negative 3 is negative 12 plus 9. After distribution, we combine like terms. 5k minus 7k is negative 2k minus 15. Greater than or equal. Then we say we have a negative 12 plus 9, which gives me 4k. Negative 12 plus 9 is negative 3. Then we want all the variables on one side. So I'm going to say minus 4k. Whatever I do to one side, I do to the other. Cancel, cancel. Negative 2k minus 4k is negative 6k. Next, we want to get the negative 6k by itself. We're going to undo the subtraction of 15 by adding 15. Whatever we do to one side, we do to the other, giving me negative 6k is greater than or equal to 12. Next, we undo the multiplication of k by negative 6 by dividing by negative 6. Whatever you do to one side, you do to the other. Cancel, cancel, gives me k. Now, because we divided both sides by a negative, we have to flip the inequality. 12 divided by negative 6 is negative 2. All right, next we're going to plot the negative 2 over here. Because it says k is less than or equal to, we're going to use a bracket. And because it's pointing to the left and it's lesser, we're going to go to the left. So we use a bracket going to the left. Let me just shade it in. All right, so if you go to the left forever, we end up with a negative infinity. So whenever we write this as a interval notation, we put negative infinity all the way up to negative 2. And because we include it, we use the bracket for that interval notation. Scroll down a little bit more. Now, in these cases, there are fractions. So our first step in these cases are going to be to get rid of the fractions, just like it was a regular equation. And so we have a 4 and a 3 as denominator. So the first question is, well, what's the least common denominator between a 4 and a 3? The answer to that would be a 12, right? You could say 4, 8, 12, or 3, 6, 9, 12. And the least common multiple of both of those would be a 12. So we are going to multiply the entire equation by 12. So first one we would say, well, 12 times 3 over 4. 3 times 12 is 36. 36 over 4 would give you a 9. Or you could just say, you could cancel some of these out. For instance, you could say 12 over 1 multiplied by 3 over 4. You could divide both the 12 and the 4 by 4. 12 divided by 4 is 3. And then you'd have 3 times 3 is 9. So either way, you're going to get the same thing. So that all that was just to simplify the fraction. All right, so over here, same kind of thing. And I'll be a little clearer about what I was talking about here. Since you're multiplying fractions, you could actually write it over 1 like this. So you could say 12 times 2 is 24. And this is not wrong. 1 times 3 is 3. 24 divided by 3 is 8. So you could do that. But I could have also said, well, both 12 and 3 are divisible by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. And you'd have 4 times 2 is 8, which would also give you the exact same thing. So feel free to simplify your fractions before multiplying if you want to. Or multiply them through and simplify them at the end. It's fine either way at this point. Okay, so next, after getting rid of your fractions, now it's time to get rid of the parentheses by distributing within the parentheses. So we say 9 times x is 9x, 9 times negative 6 is negative 54. Then we say less than, 8 times 5x is 40x, 8 times 1 is 8. All right, so now we want to get all the variables on one side, all the constants on the other, minus 40x, minus 40x, cancel, cancel. We'd say 9x minus 40x is negative 31x, minus 54 is less than. We bring down the 8. Next step is to get the negative 31x by itself, so we add 54 to both sides. 54's cancel out, leaving me negative 31. X is less than, and we would say 8 plus 54 is going to be 62. We undo the multiplication of x by negative 31 by dividing by negative 31. Whatever you do to one side, you do to the other. Cancel, cancel. And you would end up with x. Now, because we divided both sides by a negative, we need to flip it from less than to greater than. And we say 62 divided by 31 is the negative 2, right? So positive 62 divided by negative 31 is negative 2. Next, we plot the negative 2 over here. Because x is greater than negative 2, it's going to face the right, and because it's just the inequality without the equal part, we're going to be using a parenthesis. Shade all that in. And if you go to the right forever, there's an understood or implied positive infinity there. So you would write the smaller number, the negative 2, all the way to the positive infinity on the right, and you, in this case, you would have a parenthesis next to both of them. All right, now let's move on to a three-part inequality. It seems more complicated than it is, but you're basically just doing the steps twice. So for instance, I'm going to plot negative 3 right there. Now because x is greater than or equal to negative 3, well, let's say this more simply. Let me also plot the positive 2. Let's do this. We'll not get too conceptual at this point. Okay, so I plotted the negative 3 and I plotted the 2. Next to the negative 3 is the inequality with the equal sign, so that is going to be a bracket. And next to the 2, there's the inequality symbol without the equal sign, so that's going to be a parenthesis. And they're both facing inwards because that's where the x is. It's in between, right? So we just shade in the difference or in between there. There we go. So now we're going to say negative 3 to positive 2 with a bracket next to the negative 3 and a parenthesis next to the positive 2. Okay, so let's do another three-part inequality. The difference between this one is it hasn't been solved for the variable in the middle. Okay, so we are going to have to solve for the variable in the middle. So same rules that we had before, but instead of trying to get the variables on the left or right, now we're trying to get all the variables in the middle. So we have 3x in the middle. Now we want to get rid of the constant. So we're going to undo this subtraction of 5 by adding 5. And whatever you do to one side, and instead you're going to do to all three sides. Okay, so the same kind of concept, but you're going to generalize it to three parts. 4 plus 5 is 9. Keep the 3x. 10 plus 5 is 15. Now you're going to undo the multiplication of x by 3 by dividing by 3. Whatever you do to one side, you do to all three. And 9 divided by 3 is 3. 3x divided by 3 is x. 15 divided by 3 is 5. So we are going to plot the 3, and we are going to plot the 5, and the x is in between. Then we're going to shade the in between like that. Okay, so we put bracket next to the 3. We put a parenthesis next to the 5, and there you go. Bracket 3 to 5 in parenthesis. Okay, the next one, it's similar, but this one actually has a fraction. So we probably want to multiply and get rid of the fraction right off the bat. Since there's only a 3 denominator in the entire thing, we're going to multiply everything by 3. So negative 4 times 3 is negative 12. 3 times 2 is 6. 6 divided by 3 is 2. 3 times negative 1 is negative 3. 3 times 8 is 24. Now we want to get this 2m by itself, so we have to undo the subtraction of 3 by adding 3. Whatever you do to one side, you do to all three. So you say negative 12 plus 3 is negative 9. Keep the 2m. You say 24 plus 3 is 27. And at this point, you're going to undo the multiplication of m by 2 by dividing by 2. Whatever you do to one side, you do to all three. Now at this point, you need to graph negative 9 halves on this graph and 27 halves. Now, you probably want to write them as mixed numbers to do that. So, for instance, you would say 2 goes into 9 4 times. 4 times 2 is 8. 8 from 9 is 1 with a remainder of 1. And you write that as a mixed number of 4 and 1 halves. The other one is 27, so you would basically do the same thing. Say 2 goes into 27 13 times. 13 times 2 is 26. 26 from 27 is 1. Remainder of 1. 13 is your new whole number. The remainder is going to be the numerator over the old denominator of 2 or the divisor of 2, depending on how you want to think about it. This makes it a little easier to graph, hopefully. And this is negative, and the other one's positive. So you have negative 4 halves. So it's right between negative 4 and 5 right there. And then you have positive 13 halves. We're going to have to use our imagination because I wasn't clever enough to make this bigger. So that is my bad. So it's over here somewhere. Because you have an inequality on the left with the equal sign, that's going to be a bracket. Because you have the inequality on the right side that does not have the equal sign, you're going to be using a parenthesis. And you shade it all in. Right in between both, right? Okay, so from there, you're going to write this in interval notation. So it basically just look like this, right? You can actually write that as an improper fraction. You don't have to simplify for my math lab usually. But you have a parenthesis next to the negative 9 half, and you have a bracket next to the 27 halves. There you go.